Okay, this next one is one that I know I've had on versions of the test. And some people make the mistake of doing it as if they can just go directly to Newton's second law, F equals ma. Because they look at it and they see, oh, okay, there's a force, there's an acceleration, and the unknown is the mass. So since I have force and acceleration, I can take that number, divide it by that, and that will give me the mass. But you will be wrong, because the 109 newtons is not the unbalanced force. The 109 newtons is the applied force. So since it's the applied force, I do have to have a picture here. So I'm going to have let's say here's a stone, and we're going to have the weight down, and we're going to have an applied force up. And the applied force is given in the problem as 109 newtons. So we know what that is. The acceleration is given in the problem as 12 meters per second squared. And this would be the weight. So before, some of the 109 is going to be needed just to overcome the weight of the stone, especially if it's accelerating up. So my descriptive equation, if I sum up my forces, it's going to be applied force minus the weight equals ma. Applied force minus the weight equals ma. Now, I know the applied force, so if I do a checklist here, I know the applied force, I know the acceleration, I don't know the weight or the mass. Well, the unknown in the problem is the mass. So what I'm going to do is I know I can write the weight as mg. And if I write it as mg, then that will be the only unknown in my equation. So I will have Fa minus mg equals ma. And the mass is the unknown. So if I do I'm just doing algebra now. So in order to get the mass, well, first I need to get all terms containing the unknown on one side. And the unknown is in the second term and the third term. So I need to move this to the other side. So I'm going to get Fa equals ma plus mg. And then when the unknown is in more than one term, what do? Factor it out. So we're going to get Fa, when we factor out the unknown, we're going to have m, and then a plus g would be what I'd have if I factor out the m. Now the m has been separated from the a and the g, and the operation is multiplication. So if I just want m, I'm going to divide both sides by a plus g, and that's going to bring it down here. So the mass is going to be Fa divided by a plus g. And so for the applied force, we're going to put in 109 newtons. And then a plus g. So the a is 12 meters per second squared. And the g is 9.8 meters per second squared. And if you solve that, now I've had people who get all the way to here and they get the wrong answer. What they do is they go 109 divided by 12 plus 9.8, and they'll get the wrong answer. Because when you have two numbers in the denominator, you need parentheses. So you want to go 100, unless you just add them in your head. So you go 109 divided by, open parentheses, 12 plus 9.8, close the parentheses, equals, and that will get you the right answer, which was 5 kilograms, exactly 5.0 kilograms. All right, any questions with that? That took about